Hi, I'm Karina Gabrielle. So today's discussion is going to be about the multiverse theory. So essentially, what the multiverse theory is, it's kind of just a little bit self-explanatory. It's broadly that our universe is just one minuscule part of a larger picture. There are a bunch of concepts and different theories, but pretty much the idea is that there are more universes than our own, or that our own universe is larger than what it actually is. So Dr. Max Tegmark is a physicist and a professor at MIT, and he's proposed this 4-level classification of possible types of universe. So level 1 is pretty simple. It's just an expansion of what's beyond our own observable universe. So yeah, that's pretty much what level 1 is. Level 2 explores the theory of inflation and pocket universes. Level 3 poses the idea of many worlds, quantum mechanics, and daughter universes that are infinitely reproducing for every action that's taken. And level 4 explores the idea of a mathematical universe where every mathematical system is a physical reality. So let's go into level 1. So level 1 of Dr. Tegmark's 4 levels of classification is the most tangible. It just explores the idea of an expansion of our own visible universe. So when we talk about like the universe in modern science, we're not talking about everything that exists. We're talking about what's observable within our range. So everything that's within our Hubble radius, which we can see, is pretty much, it reaches back to like shortly after the Big Bang, so about 13.8 billion years ago. And because of the expansion of the universe, it's stretched out space. So we're actually able to see about 42 billion light years away. But essentially level 1 poses an idea that there's more to the universe than what is observable. Just because we can see 42 billion light years away doesn't mean that our universe ends there. There might be a galaxy 42.3 billion light years away that we cannot see. And just because we can't see it doesn't mean it's not there. So yeah, that's pretty much what that idea poses. And also the other idea that it poses is that that we live in an infinite ergodic universe, which includes an exact copy of you. And what an ergodic universe is pretty much, again, just every sort of outcome that is tangible, I would like to say. Like it's a little harder to explain, but pretty much what that would include is an exact copy of you within the same universe. So that's what's level 1. And level 2 is the theory of inflation and pocket universes. So pretty much the theory of inflation is it proposes an exponential expansion of the universe within its first moments of existing. So within like trillionths of a second of the universe being born, it infinitely expanded, like exponentially expanded. And so the theory goes to propose that expansion stopped at different points in different parts of the universe. So it creates little pocket universes elsewhere where like these different expansions stopped. And so within these pocket universes, they also might not follow the same laws of physics as our own. And so pretty much this also kind of adds to the idea that we simply lucked out and found ourselves existing in a universe where we're fine-tuned to support life, pretty much. It also attempts to use string theory to connect general relativity to quantum mechanics, and it suggests that any solutions that are produced by string theory that don't match up or correlate within our own universe is simply just a blueprint for physical law in another pocket universe. So that's just a nice little summary of what level 2 is. And level 3, my favorite level, pretty much explores time rather than space. So pretty much the theory of many worlds insinuates that there's a multiverse for every possible future outcome in regards to quantum mechanics. So quantum states are simply just wave functions of objects in our universe. Everything has a wave function in our universe, you know, from this AirPods case to a cat. Everything has a quantum state. and wave function. So the idea is pretty simple. For every decision that we make, the universe branches out into two separate universes. So I have two objects in front of me. I have this case of AirPods and this mouse. So for each universe, I can choose to put down these AirPods, but I just created another universe where instead of putting down these AirPods, I put down the mouse. So that's what that explores. And a more like common experiment that is used to explain that would be like Schrodinger's thought experiment. So Schrodinger essentially hypothesized that if you put a cat in a box with anything lethal that could kill it, let's say poison, the cat, you wouldn't know until you open the box if the cat was dead or alive. And so while the cat is in the box, the cat is both dead and alive. So yeah, but if we open the box and the cat is dead, this creates another branched universe where the cat is alive when we open the box. So that's what that is. And so both features will continue in the same perspective as if the other outcome never existed. So this theory kind of just generates an infinite amount of daughter universes that pretty much just exhibit every possible outcome ever. So that's what level 3 is. And level 4 is the mathematical universe. So all previous levels, like they keep the fundamental laws of physics in mind, but Dr. Tegmark refuses to stop there. He believes like why stop at just trying to change, space and time, but actually change the whole physics, or like, yeah, the whole idea. Pretty much it's this whole idea. It's a little hard to explain, but he describes that the last level is every physical reality is not governed or described by math. It is math. The last level is that all of our universe and every single physical reality that exists is just math. Our physical world is just one huge mathematical object, and all mathematical systems are described by a physical reality, and that's pretty much it. That's all it is. Yeah. Alrighty, so that was my little lesson on the multiverse theory and Dr. Tegmark's 4-level concept of multiverses. Thank you.